Hello, everybody, and thank you for being here. I hope that you're enjoying your third day at ChangeNOW. And today, this afternoon, we're going to talk about microplastics. So microplastics are very small, very tiny, hardly visible. Because we don't see them, a lot of people, they don't think that's a pollution, yet they are everywhere. They are everywhere, and that's a big issue. They are in rivers, they are in the soil, they are in underground waters. They travel with wind, they travel with water, so we can find them deep down in the ocean. We can find them at the top, top mountains in this world. And we don't know it, but we eat and we drink microplastics every day. And so on average, it's been calculated that we absorb 5 grams of microplastics every week. So that's the equivalent of a credit card. So small size, big consequences. Today, we're going to talk about what microplastics are, where they come from, and how we can stop that pollution. So we're going to start with 2 young women that are working and bringing their energy and leadership to fight against microplastics. So let's applause Meek and Imogen. Please come on stage. Please sit down. So thank you very much for being here. So very quickly, and correct me when I say stupid things. Amy, you're just 18?
Yes, 18.
Yet, if we look at how much time you spent working against plastic, you're already a veteran. You started at 12 years old. You realized how bad the problem of plastic was, and decided to start, to act. You decided that you could do something, and you started your charity with your younger sister, 10 years old at the time.
Mm-hmm.
And that you created Kids Against Plastic. And since then, you've been very active. That's thousands of kids that you've been talking with. You've talked with ministers, you talked with government officials, at the UN also, I heard, in Geneva. So congratulations for this. We talked just after. And Imogen?
Mm-hmm.
So you're not 18.
A little bit older.
And for you were a surfer. You still are a surfer, I understand.
A bad surfer, but still trying.
Yeah, but that's still better. And you realized, being a surfer, you started to be aware of plastic pollution, and then you decided to work on this, and you did a PhD at the University of Plymouth.
That's right.
Correct. And then starting to work, research on and studying, okay, where does plastic comes from, where microplastics come from, and some places where we don't think there's plastic in. And so one of the examples of your work is you found that there were so many plastic microbeads in facial scrubs, and then started to voice against this, and the end was that it's now banned in most of the world, so congratulations for this. And now, so you're working as an explorer for National Geographic, and so my understanding is that you're working in the Gange River right now. We're studying where does plastic come from in the Gange River.
So that expedition is finished, and we actually have the results published that I'll tell you about in a few minutes.
Okay.
But yeah, it was a really exciting trip.
That's great. So thank you very much. Amy, we start with you. So tell us how it happened. Why you decided to fight against plastic?
Well, I think, as you said, we kind of just came across the issue of plastic quite broadly, and it was back in 2016, so I was 12 years old, my sister was 10, and it's been remarkable how much has changed in the last 6.5 years we've been running our charity when it comes to awareness of plastic, because 6.5 years ago when we started this, Blue Planet 2 hadn't come out in the UK, there weren't as many news articles, there weren't as many films about it. It really wasn't an issue that was talked about as widely as it is at the moment, and that was what really worried us in particular, because there's so many environmental issues facing our planet, but plastic in particular is one that we are all contributing to in some way, but it's also one that we can all make a really big difference against. And we saw the scale of this issue, and we saw the rate at which it was getting worse, and we thought, if we sit here and we turn a blind eye to this and we move on, then where's the guarantee that someone else will do something against this issue in time? And so that's really how Kids Against Plastic came about, as a very, very primitive, small campaign that has somehow grown into a charity since then.
That's great. That's amazing. But our topic is about microplastic. Imogen, can you explain what is microplastics really?
So microplastics are everywhere, and they're kind of like an invisible plastic pollution, but one that they're in the room right now. And they're defined as being less than 5 millimeters in length and can take a variety of different forms of shapes, such as fragments, fibers, or pellets. And even the clothing that we wear, 60% of the clothes that we wear are actually made out of plastic. So as we're sat here right now, fibers are coming off our clothes and going into the air, and we could be breathing them in. So it's a very scary and prevalent source of plastic pollution.
And there's one question that I have, is the humanity polluting the environment that's been going for ages. And for example, with broken glass, that's everywhere as well. We're not worrying as much. So why are we worrying so much with microplastics?
It's actually a really similar story to you, Amy, that I grew up in a small seaside town called Clevedon, which is in the southwest of the UK. And when I was younger, I never remember there being any plastic pollution on the beaches where I grew up. And now I go back home, and there's beach cleans, and it's just visible. And I'm sure, like the audience, you've all had a similar story where you've seen litter and beach cleaning more prevalent than ever before. So the problem is that plastic's a victim of its own success. It's so persistent, and it's durable. And when I started my PhD, I actually thought that plastic was the devil, and the only way to clean up the oceans was to completely get rid of it. I was actually completely wrong. It's a fantastic material, but it's how we use it that's the problem. And it's because we make so much of it in single-use applications that we don't necessarily need. I think the average time that we use the single-use plastic is for 3 minutes, but then it could last for a lifetime. And scientists don't officially know how long it takes for plastic to completely break down into its most basic components of carbon and hydrogen. So we really need to now consider how to use less plastics and turn off the tap so less is going into the ocean.
Okay. And tell us, what are you doing with plastic, Kids Against Plastic, to turn off the tap?
Yeah, I mean, it links really exactly to what Imogen was saying, because our work does not focus on microplastics, and yet this broader consumption of plastic links so closely to this microscopic issue. And so through Kids Against Plastic, we're really an education charity at heart. So a lot of our work is around turning off the tap of plastic. So it's around cutting single-use plastic usage down in all different sectors, not just individuals, but schools, businesses, festivals, because really there's an overuse of single-use plastic almost everywhere, and that means that everyone has a part to play in helping to address that. So we run our Plastic Clever Scheme initiative as part of that, and we also do a lot of work with young people, because the younger we can learn about this issue and grow up with better habits with our consumption of plastic, more aware of the environment around us, then the more likely we are to care about it and ultimately to take that important step of taking action.
And so could you share some concrete examples of actions that you're bringing?
Yeah, I mean, for example, with the schools initiative, so we have 1,400 plus schools that are signed up to that initiative from all around the world. I was visiting one just last week, actually in my local area, who through the initiative have audited the plastic in their school. They've taken steps to reduce their top 4 items. They're spreading awareness in school, going on litter picks, and really creating that energized environment of kids who are sharing inspiration, but also knowledge around this issue. And I think that action of young people and that inspiration actually links a lot to the club that we also run as part of our charity, where we have kids from the age of 5 years old who are dragging their parents out for litter picks, not the other way around, and have got plastic bottles to be removed from their school, or have run a campaign that have got over 65,000 signatures to get UK magazines to stop selling them with plastic toys. So really inspiring to see actually how everyone can have a role to play against this issue, but especially young people.
Okay, great. And Imogen, Amy just mentioned getting rid of plastic bottles, so that's not microplastics. How do we relate everything together?
So there are 2 sources of microplastics. The first is primary microplastics that have been made to be that size, such as microbeads and facial scrubs. And then you have secondary microplastics, which are microplastics that have been degraded from larger items. So when you go on a beach clean or a litter pick around your local area and you see a bag or a bottle, if that's not cleaned up, then eventually, by weathering, such as sunlight, or even just being tossed around the ocean, it would break down into hundreds of thousands of tiny plastic pieces. And it's predicted that all of the plastic that's in the ocean if we stopped all of the plastic entering it, the microplastics would still rise.
Okay, so eventually every plastic will end up as microplastic.
Eventually, exactly.
Okay. And in broad mass, could you share with the audience where does the plastic pollution comes from?
It's so complicated. It's this huge jigsaw puzzle, and it's really hard to have a concrete answer. But some of the research that I've done has shown the variety of it. So we did some research looking at microbeads in cosmetics. And these are tiny plastic particles that they used to put into facial scrubs to act as exfoliants to get the dead skin cells off. And no one had done any research before looking at how many could be in one bottle. So we decided to do that. And it took me absolutely ages in the lab. I was there till silly o'clock in the morning for absolute weeks, just extracting all of these tiny plastic particles. And it was just taking so long because there was so much in there. And we found that 3 million could be in one bottle. So on a squirt on your hand, every time you wash your face, there could be up to 10,000. And then these could go down the drain, potentially through the sewage treatment works, and then into our oceans. And we were able to utilize that research to make legislation change around the world, because it's completely unnecessary, and there's natural alternatives instead. Then we also did some research looking at washing our clothes, because like I said at the beginning, most of the clothes that you're wearing in the audience, and check when you get back to your accommodation and the label to see if it's made out of plastic. And when we wash our clothes, we found that 700,000 fibers on average could come off your clothes and potentially make their way into the oceans. So I've been best called a plastic detective, and having a look at the ways that plastic's getting into our environment from ways that we don't typically consider.
So, I mean, basically that's what you found with your work, your research work, to see some specific sources. But do we have an idea how much comes from, let's say, bottles, how much comes from, I don't know, automotive or whatever part of plastic, the different plastics that we produce in the world?
So we have some research coming out in the next few months, so watch this space, because I'd love to tell you more about it when it's published. But it's looking at the fragmentation of larger items and how quickly it could happen. But it's quite scary.
Okay, thank you. Amy, so we're talking about the research side. How do you integrate all that research in the actions you're doing with Kids Against Plastic?
Well, I think the research is so important because it underpins, exactly as Imogen said, all of the important action, to build upon that research. And whether that's legislation, like against microbeads, that obviously had such a massive global impact, or whether it's through the actions that we actually implement in our own lives, which can feed into those larger changes. And I think a lot of our charity is around the action that we can take, because it's great to learn about these issues, and the research is so important as part of that, but we actually need to turn that into something that will make a difference against this, so we can try and reduce that output in the first place. And especially working with young people, I think it's so important that we understand this, and the research is such an important part of that. And it's how do we translate that into something that's accessible for everyone as well, because, for example, we haven't got 8-year-olds that can pick up a scientific paper and read it. I'd be very impressed if they could. I mean, I'm sure some of them probably could. But how do we turn that into something that even the youngest people in society can be engaged with and can understand? Because ultimately, to make a difference against an issue like plastic, we all need to be involved in all different stages of life and all different areas of society to make a difference. So we really try and translate that into things that we can do to start off with as individuals, so even something as simple as cutting our plastic usage, and then going further from that to actually look at the wider issue and the way you can raise your voice and build upon this.
But so one of the actions that you're making is getting rid of some products made out of plastic. But it's not always easy. Wouldn't it be simpler just to create a material that is biodegradable and to replace that plastic?
I think, it's interesting. I'm sure there's many conflicting opinions on this. We were talking about this just before we came on as well. And to be honest, there's no easy answer, because the thing is, exactly as Imogen was saying, it's not like plastic is this completely negative material, in its core. The way we're using it is very negative. And so when we look at biodegradable plastics, in some situations, they can be great if they're disposed of correctly with the right conditions, if they're used for the right thing. But if we're deciding that, okay, we're going to try and reduce our consumption of plastic bottles, and we're going to do that by swapping it out for a biodegradable plastic that goes on the supermarket shelves, which then isn't disposed of correctly and actually becomes an even worse pollutant or a contaminant in recycling, then we're kind of creating more problems for ourselves instead of trying to solve the ones ones that we already have. And ultimately, swapping out one material for another doesn't really address the root cause of plastic pollution, which is our overconsumption of it, because we're producing and discarding such a huge volume of plastics that it doesn't matter whether it is plastic, biodegradable plastics, aluminium, or paper. We really need to try and look at what underpins this whole issue as a whole, and really that is overconsumption, and so we also need to look at trying to cut it at the source as much as possible.
Okay. And Imogen, I think you did some research on biodegradable plastic. Can you share some results?
Yeah, it was quite controversial, and it was it was the longest experiment that I've ever done. It was the whole length of my PhD. So it was the first experiment that I set out in my PhD, and the last one that I took samples from. And we took samples every 9 months, and we buried some biodegradable plastic bags in the soil. We submerged them in the ocean, and we left them hanging outside. And in true Blue Peter fashion, we just purely wanted to see what happened and if they actually did biodegrade. The ones that were outside completely fragmented into tiny bits. It doesn't mean that it's necessarily disappearing, it's just fragmenting by weathering. And then the ones that were in the soil, all of them were still there and they could still hold a full bag shopping. And the ones that were submerged in the ocean, after 3 years as well, they were still there and they could still hold a full bag of shopping. And we're not saying that they're not a solution, but they often need really specific conditions to break down, like high moisture and high heat, or maybe a really specific pH. So it needs to be in a proper closed-loop environment where it's going to have those specific conditions. So it opens that discussion of potential greenwashing and making sure that consumers and industry have proper labeling and proper standards so we know how an environmental product works, so we can make the best decisions for it.
So not necessarily a solution.
A solution, but in the right environment. So if you had a football stadium and you're having your beer in a cup, and that was biodegradable plastic, if all of them could be collected and go to the right waste stream, then that would work. Mm-hmm. But for Joe Bloggs down the street that has a biodegradable plastic bag and just puts it in the normal waste, that's going to provide no benefit potentially.
Okay. Amy, you mentioned your work about sensibilization, creating awareness, but there are so many hours that you have in a day, so you cannot go in all the schools everywhere in the world. So how can you scale your action to increase your impact?
Yeah, I mean, I would love to be able to go and speak to kids in every school in the world. But yeah, it obviously, you know, I'm going to university this September. It is something that time management is something we're aware of. But actually, I think we've kind of tried to turn it into almost the superpower of our charity, because ultimately our charity has never just been about us, me and my sister, and ultimately it's never just been about plastic either. It's also been about the kids part of the name of our charity as much as the plastic, because we've seen over the years really the influence that even young kids of the age of 5 can have on their communities, their families, even broader than that. And so while we're looking at the fact that, okay, I'm kind of pushing the boundary of being called a kid now, I'm still trying to remain youthful at 18. So how can we look at actually the longevity of our charity isn't just the work we do against plastic, but actually ultimately how we empower and educate and really inspire these young people to be the next change makers, because we firmly believe we are ordinary kids and anything we've done is something that anyone can do the same. And we've already seen the amazing young people we have as part of our club who are 12 years old or running a charity, running a campaign, working in their school, leading the way. And so they're already doing so much at that age that by the time they're my age, I'm sure Kids Against Plastic could be in their hands and going a very different direction.
Okay, great. And do you want to share with this audience one last thought about how to fight microplastic pollution?
One last thought. That's very tricky to narrow down to one, but to be honest, I think what microplastics does is kind of put into perspective the impact that even tiny things can have in a way, because if we're learning about how it's in the air, it's in something that comes from our clothes, it comes from items we use all the time, and yet they're so tiny, most of them are even invisible to our naked eye, and yet they're having such a disastrous impact. They're in our bloodstreams, the toxins are having such a negative effect on our health and environmental health, and then you look at these tiny fragments or fibers and you think, how can that make such a massive detrimental impact on our planet? And I think we so often disregard the small things that actually make a big difference. But I think if we flip that and we look at it in a more positive note, and we look at how can we start to address microplastics and microfibers, I think it's not thinking about the scale of this issue and thinking this is massive and untouchable and I've got no idea how I can prevent all microplastic pollution, and actually thinking, if these tiny things are making such a big difference, then the small changes I make can also make such a big difference. And so whether it's looking at your clothes, like Imogen said, and just trying to think more carefully about the materials you buy, or even how often you wash your clothes, and actually just think of the small changes that you can make that, if they're amplified and done collectively, like with microplastics, could actually make such a big positive difference on the environment as well.
Okay, great, thank you. And Imogen, in terms of research, what are your next research that you want to conduct to have even more power, even more capacity to fight against this pollution?
So I've gone on a bit of a crazy streak, and this is some research that I'm really enjoying. But we're looking at waste as a whole and our overconsumption and need for more legislation and rules. So we're comparing ocean debris to space debris and the comparisons. So it's, again, a watch this space kind of moment.
Okay. And I mean, anything, also any last thoughts you want to share about what you want people to do to act on this matter?
Probably literally exactly the same as you, Amy. I think research has shown me that you can have such a substantial impact by making small changes, and I think that's thrown around a lot and disregarded, but it's so important that choosing a facial scrub that hasn't got microbeads could stop millions from reaching the ocean. Only washing your clothes when you need to could stop hundreds of thousands from reaching the ocean. So the power of small changes, and also reconnecting with the environment and reminding ourselves how lucky we are to have this planet and why we need to protect it, and using that energy to make the right decisions.
Great. Thank you to both of you. I think they need a big applause. And just invite you to follow the rest. So I think with this first part, we understood that we can make change, whatever how young we are, whatever if we think that we just want small parts in the world, by changing our habits. That's something we can help curb the pollution of microplastics. But then there's what's already there. And how do we get rid of the pollution that's already in the nature? And we have someone here that thinks that he might have a solution. So that's Fionn Ferreira. So he's an Irish student studying chemistry, and he invited a technology to clean water from microplastics. And that's something involving magnets, and probably that's how he attracted Iron Man. So he's got Robert Downey Jr., so the coalition, the foundation that is supporting him, and also got rewarded by Google. And please come on the stage, Fionn, and I leave the floor to you to explain your technology.
Yeah, so thank you for that. First of all, I love being associated with Iron Man. I wish I would look like Iron Man. Sadly, that's not the case. But what I really, really enjoy doing is just playing with science and playing with different things that happen to be in my backyard. And this is pretty much what I do at the moment, just that I don't own a backyard. I own a balcony and a smaller apartment because I'm a student. But I still really enjoy inventing and playing with science. And that's something I think you all need to do when you get home. So if you still have that box of Legos from your childhood in your attic somewhere, please, as a promise to me, take that out and start playing with it this evening. Promise? Okay, good. So now I can begin. So I grew up in West Cork in Ireland. So essentially in the middle of nowhere. Like, my house was the third last house on the electricity line before you fall off a cliff and get into the ocean. And really, to get to a city was like really, really, really far away. But I did realize something that I loved, and that was being outside in nature and being outside and being able to connect with the environment and experience it. I did a lot of sailing, a lot of kayaking, a lot of walking on the coast. And these are sunny days in Ireland. I don't know if any of you have been to Ireland, but sunny days are actually not that common there. We also have rainy days, and on those rainy days, I was playing with my Legos and Arduinos and trying to build different devices to do whatever I wanted them to do. And ultimately, that taught me two things. One is that I like environment, and two, I like inventing things and playing with things. But while out in the environment, while I guess sailing and while kayaking, I saw a lot of plastic on our shores. And at first, it was just something that annoyed me because I felt like it looked kind of strange and out of place and colorful, but I didn't really know the problems associated with it. And I thought, well, these big bits of plastic, well, what animal would want to eat this? How would this get into an animal? How would this harm an animal? And that was something that at first I didn't really worry about, but more I just thought was something that was annoying. But I decided to look more into it, and that's when I started coding and playing with a couple of little robots and things to just casually go along the coast and identify plastics and be able to count them from an image. I actually coded a macro for Adobe Photoshop that if you took a picture of a coast, it would try and identify plastic. And like that, you could actually quantify maybe the plastic on the shoreline. So as a result, I realized there was actually quite a bit of this stuff there. And it wasn't the same plastic, which I initially thought, but new plastic being washed up and being washed away with the tides on the Atlantic. And then I did some more research into what was happening to this. And that's when I realized that there's, the small microplastics, which we've been talking about for the last half hour or so. And these small microplastics were something that I got quite scared about because I just saw that, they're really, really small, but also they're really difficult to test for. A lot of people are talking about how, there's X amount of microplastics in this product or there's X amount going into the sea every day. I think that's a really unrealistic estimation. I think there's probably a lot more microplastics going into the sea every day because it's basically impossible to test for these microplastics. And that's actually the first thing I hope you take home from my talk, is that microplastic testing is still such a big complication and such a big requirement for us. We really, really need to develop new technologies to test for plastic. But I thought, well, I'm in the middle of nowhere in Ireland. I'm quite far from the nearest lab, like 4 hours drive or so. I couldn't drive, so that already solved that problem. But I thought, what if I use my Legos to build a device to test for plastics? And that's essentially what I started off with. Out of my Legos and out of a camera, I built a visible light spectrometer. So the theory behind that is that if we shine light at a sample containing plastic, the molecules inside the plastic start, getting excited, just like me when I came onto stage with the music, and that changes the light that goes through. And then what we get back is something missing a couple of parts of light. And those little bits of light that are missing, that is what's telling us that there's plastic there. So I built one of these. This was not easy. I had to, take apart our fridge and a couple of other things to get components and then try and put them back together before my parents found out. It also caused a couple of power cuts in the district, but nothing that couldn't be handled. But I realized that actually I could create a pretty interesting piece of kit to test for plastics relatively simply. And that's what I did. So I started testing for plastics, and I realized that plastics were literally everywhere. So much so that the water that was coming out of my tap from a 200-meter well beside my house contained plastic. And when I washed my equipment with it, I was actually leaving behind plastic. I don't know if, Imogen, you have this issue as well, that when you're actually working in a lab, it's so difficult to not contaminate your samples. So when I was working in a lab, I wore an orange lab coat so that then I would see orange pieces of plastic if there was plastic coming from the coat. But with that, I realized that there was plastic, and this was very small plastic. So small that a filtration technology, a filter where we can put water through, just wouldn't work. Because some of these plastics are so tiny that they can be smaller than red blood cells in terms of just a couple of monomers. And then we're getting into a molecular scheme. That's why I thought, well, what if I think back to high school science class, right? And think back to ways that we can separate very different nature molecules from a bulk solution or bulk suspension of other molecules. And I thought of something that probably most of you did in high school chemistry class, and that was a liquid-liquid extraction. So you put one layer of something of one polarity on top of another, and you can actually perform an extraction, right? So nonpolar things will tend to be solvated better in a nonpolar solution. Sorry, guys, I'm going to try and limit the chemistry as much as possible. But ultimately, I was able to use an oil mixture to extract plastics out of a bulk suspension of water. This worked reasonably well. I tested it with my makeshift little machine that caused the trip switch to trip every 20 minutes. And I saw that this method worked relatively well in the removal of microplastics from water, so approximately 80%. But what do I do with oil? I've got oil sitting on top. We don't want to build oil spills, right? So that's what I thought, well, what if I turn to my physics class? I was 16. And what if I use a magnetic suspension? So I add some little magnetic particles into the oil, ideally magnetic particles that are safe for the environment. And then those magnetic particles, I can basically turn the oil into something called a ferrofluid, or magnetic liquid. So I start playing with this first, just playing with ferrofluid, because they're pretty cool. They make like nice star-shaped structures when you put them in a magnetic field. But then later, I discovered that these could be used to attract microplastics from water using magnets. And actually, I then did a very, very small experiment. I still have the original video, which I gave to the technical department. So if they could put it on at some point, that would be good. Like I have, oh, here we go. And I basically started by adding microplastics to water just to see. And then I added some just plant oil, cooking oil, and then a little bit of magnetite powder. So this black stuff, this is like rust powder. And then I mixed it up, and it looked pretty manky, or dirty. In Ireland, we say manky. And then I brought in just a test tube filled with magnets. And I wanted to see if I could attract the mixture of both the plastics, the oil, and the magnetite together. And would this be a reasonable or viable method? And it looked like it worked pretty well. So that's what really started me on this journey. I don't have quite enough time to, I guess, explain everything that I've been doing since. But for me, this looked like it worked relatively well. So that's why I thought, well, what if I build a better version of my visible light spectrometer and build a backup device, as one does, to test this in 2 ways. I think 2 is better than 1. So I built this visible light spectrometer and a microscope, and then paired those 2 technologies to try and look at microplastics. And I saw that my method, at least on a scale like this, in a little test tube, was effective to approximately 87%. But I wanted to see how we could apply this into the real world. And that's what I'm currently doing and still doing. So I tried, and with the funding of Robert Downey Jr.'s Footprint Coalition, I've actually been able to create this into a continuous flow device. So a device where water flows in, and it goes through a layer of this magnetic suspension, and then the plastics hopefully stay in that suspension, and then it flows out through a series of traps. I can't show you a picture because this is still something in development. But when it's out, yeah, if you follow me, or if you reach out to me and want a picture, yeah, sure, I'll send you one. But this device is showing really, really nice results and really exciting results. And for me, it's not just about creating a technology that we can clean up plastics with, but more about the journey of seeing one of my little things that started as a couple of blocks of Lego and a little bit of kayaking on the coast in Ireland turn into something that perhaps is something viable and useful and something that we can use to actually change the way that we live. Microplastics have been seen to cross the blood-brain barrier, and they've also been seen to be absorbed relatively easily. However, this is all very continuing and ongoing research. But what I believe is that we all need to engage a little more and play a little bit more with our science. I think we shouldn't be afraid to just leave the innovation and the idea generation to scientists, to people in labs, because often they are in that lab and they perhaps have not got the exposure that you have to the world. Everyone has a unique place in the world, and I think that through perhaps exposing yourself to multiple things and letting any one of your ideas count, I think you can truly make a difference. But something I would also like to highlight is that what I've created here, I do not think is the solution, right? Because I'm just cleaning up plastic. But the ultimate solution is that all of you guys stop creating plastic and microplastic waste and perhaps try and redesign the whole ecosystem of plastic. And I think that's not just you, but also bigger companies. So that's why I'm actually currently working on trying to get more companies involved. I'm actually launching an NFT-style project where I think we can use blockchain technologies to reward companies for their goodness in terms of not producing plastic pollution or microplastic pollution. And through this, we can perhaps reward companies with an NFT, which they can then use on branding of their products. So this is just a very grassroots idea which I have, which I'm actually pretty much launching and bringing to the public here for the first time. But it's another result of me kayaking on the shore. So ultimately, I've achieved just a couple of small things, some of which I think could make a difference in the world, some of which I think could perhaps change the way we interact with plastic and work with plastic. But ultimately, this has been a result of me playing with science, and I urge you to all take out that box of Lego and play with science this evening and hopefully into the future. Thank you.
So Fionn, thank you, but I'm a bit disappointed because you said that was not the solution. But so where can you apply this solution?
Well, I think it perhaps could be one of the many solutions that we could apply for cleaning up plastic, right? Plastic, even if we stop producing microplastic pollution today, will still be in the environment for many years. And it's something where I think lots of cleanup technologies like my own and the ones that are going to speak right after me could help. Right? Because we still need to try and make water and different things we're going to consume safe for us to consume. I don't want to be consuming those 5 grams of plastic that I currently am through my water and through my food. And that's why I feel like technology like mine and other cleanup technologies are important. But they're not just important for that, but also in the importance of raising awareness, like what we're doing here today in this amazing event. We're reaching out to more people who hopefully learn about the microplastic issue through technologies like these, but also we're hopefully sparking some ideas in people like this amazing audience to change things as well.
Okay, great. And would there be some specific cases of applications, such as, I don't know, industrial waters that are polluted with microplastics, or what kind of applications do you foresee?
Sure. So I really think that this is not a technology that we should just apply in the ocean, like dumping in lots of magnetic liquid and then, holding a magnet at the beach. I don't think that's going to work. Sorry, guys. But I think a place where we could apply this is perhaps in places where polluted water is coming into the waters of the world, or where we're taking water out. So perhaps in wastewater treatment centers or effluent treatment centers, where we've got a lot of plastics in a very, I guess, well-defined scheme of water. That's at least where my research is currently going. But also in places where people are drinking water. Perhaps one of the best technologies for cleaning water in terms of having clean water is reverse osmosis, which would probably take out many plastic particles. However, reverse osmosis is not something that is very energy viable, but also is really, really slow and not efficient to, let's say, use on a whole water supply for a city. So that's a place where I envisage my technology perhaps working as well.
Okay. And if some people want to know more about your work and want to engage and support you, how can they do this?
Well, I really think that it's important that we foster, interesting conversations and hopefully talk about our other creative solutions. Like, I'm totally down to brainstorming with all of you. Maybe like not all at once, but at some point. So I really use Instagram a lot because I feel like that's a place where we can connect and brainstorm about ideas, and I can also learn more. So just with my name, I think you'll find me. I also have a platform which is very much in the early stages, where we're looking at just creating a small community of focused scientists who are sharing tools and methods to be able to do science or to work on their own creative ideas. So that's called Glick. You can find it at theglick.com.
Great. So thank you very much, Fionn.
And thank you for having me.
So this gave us a view of one promising solution to treat at least one part of microplastics. But as the microplastic issue is huge, we cannot rely just on one technology. So we need a lot of entrepreneurs that will be looking for solutions, for different types of solutions, different types of applications to get rid of this problem. And also, as Amy and Imogen said, also be very careful ourselves to change our habits to always create as little microplastic as possible. But for the next part of this session, let me introduce to 2 young entrepreneurs that also created some startups to fight against microplastic. So we have Jamie Walters, that co-founded Calyxia, and Adam Roots, founder of Matter. Please come on the stage. So thank you, both of you, for being here. So I'm going to do a quick introduction, and always, if I say stupid things, tell me and correct me. So maybe to start with Adam. So Adam, you're a mechanical engineer, and you started your career with GE and then Dyson, and then you learned about everything that you could do in terms of innovation for home appliances. But then you wanted to start your own venture. And so you left Dyson and started your own venture in Asian food. To start with.
Yeah, that's it. That's me. Yeah, so I'm super passionate about cradle to cradle circular economy and applying those principles into reality. And that's where Matter was founded, and that's what we've been working on.
So Matter was after the Asian food.
Yes. Yeah, I started a little business with my wife. Kind of got a little bit out of hand, but we were doing okonomiyaki for a little while, which is maybe a time for another story for another time, but also lots of fun.
And so Matter is a company that is working on capturing microplastics that get out of washing machines. So Imogen told us about this issue, about all that microplastic being produced when we wash our clothes. And Matter is working on this issue. And so we'll talk about it in the more deeper afterwards. And Jamie, so you're also from England. And I understand that you come from a part of England that most French people don't know that much, where coal mining was very important. And your grandfather was a coal miner, and so was your father, so was your uncle. And you were supposed to become a coal miner as well, by tradition, maybe? And living there, you saw all the effects of coal mining on the health of the miners, and in particular on your father and on your grandfather. And you also saw that when this industry went down and closed, it created a lot of issues, social issues, because there was no more work. And that created for you really this willingness to engage yourself in transforming industries so that they will be focused on the environment, good for the environment, good for society. And at the end of the day, that's how you created Calyxia.
Yeah, for me, industry is key for job creation, particularly in areas outside big cities. But industries also need to be safe, they need to be sustainable, and they need to improve the quality of life for all. So that's one of the reasons we created Calyxia, to help industries become safe, sustainable, and improve the quality of life for all.
That's great. And maybe to start with, so Calyxia is producing microcapsules. And I guess most of the audience doesn't know what microcapsules are. So could you tell us more about this?
Yeah, so I think everybody here now knows about microplastics. So microplastics are micro-sized plastics that accumulate in soils, they accumulate in oceans, they destroy ecosystems, they destroy biodiversity, and they add toxic elements to the food chain. That's microplastics. Microcapsules, on the other hand, are an essential ingredient for many home and personal care products and agriculture products too. So microcapsules are micro-sized spheres, capsules, representing a shell and a liquid core. For home and personal care products, this liquid core can be vitamins, can be enzymes, can be fragrances. For agriculture, there can be pheromones, herbicides, insecticides, fungicides. Now, microcapsules have a fundamental role in society today. Microcapsules help to protect ingredients against degradation and deliver them on command. So for agriculture and home and personal care, it helps companies reduce the amount of ingredients in their products, which helps to reduce the cost, improve the safety, improve the sustainability, aligned with many sustainable development goals. But the problem is current microcapsules have a plastic, non-biodegradable shell. And they're believed to represent about 10 to 15% of the microplastic pollution in the oceans and soils today. So this is the problem that we address, how to eliminate microplastic capsules from home and personal care products and agriculture products.
But there could be a very simple way to eliminate the problem, just ban microcapsules.
Well, I mean, so microcapsules in general have a positive impact. Like I say, they help to reduce the amount of ingredients and help produce cost-effective, safe, and sustainable products. but the problem is the plastic pollution. So I think we can be proud in this room, and proud in France and Europe, because the European Commission is implementing a ban on non-biodegradable plastic microcapsules. So this ban will come into effect from 2027, but it will ban, it's already banned plastic beads, which is fantastic, but it will ban plastic non-biodegradable capsules in home and personal care products and in agriculture products by 2027. Now, it's really a call for action for the audience here. So Europe is good, but the US and other regulatory bodies are not following suit. So as a public, and NGOs too, we need to put pressure on these regulatory bodies to also ban non-biodegradable microcapsules. And we also need to put pressure on them to increase and accelerate the ban. And that will be a huge influence that we can make in minimizing plastic pollution.
So if I understood well, the microplastics, microcapsules are needed, but the problem is that today they're made out of plastic, and this will be banned. And Calyxia, you're producing microcapsules. So your microcapsules are not plastic, correct?
That's right, we're the solution. So as we say, plastic microcapsules, they do have a positive effect today in some respects. They help companies create cost-effective, safe, sustainable, and high-performance products. The problem is that the shell is plastic. So Calyxia, I'm a scientist too. I did my PhD at the University of Cambridge, and in Paris, we developed a new sustainable manufacturing process to create biodegradable capsules. We started off with 2 people in a lab. We became 10 people in an incubator. Now we have industrial facilities serving global clients on multi-annual contracts. So today we work with global manufacturers in home and personal care, global manufacturers in agriculture, and we help them to replace their microplastic capsules with biodegradable and advanced performance alternatives. This enables our customers to be compliant with new regulations, to improve the sustainability profile of their products, and at the same time, it helps them to add new performance features to their products too, helping them reduce the ingredient further and add new functional delivery profiles.
Great. Adam, so we just heard about the solution of Calyxia, basically transforming some what would be microplastics into biodegradable material. With Matter, you are tackling this issue of microplastics with another logic, another solution. Can you tell us more about?
Yeah, sure. Thank you so much, Olivier. And amazing to hear, Jamie and your team and what you're working on. So effectively, Matter as a business, we focus on the capture, the harvest, and the recycling of microplastics. Our business is really focused about impact. We look about where the major sources of microplastics are and then develop products that match those. So as we've heard today, synthetic textiles is a massive issue. And what we're seeing is, as Jamie mentioned, there'd be global legislation happening across the world. So in France, for instance, it's been illegal to buy a washing machine from 2025 without a microplastic filter. It's a big step.
A regulation announced at ChangeNOW 2 years ago.
Yes, and thank you for everybody in the room who's involved in this. So we're super excited about that. And what there is effectively these multiple streams of pollution that's coming across. And Matter as a business has effectively developed a technology platform. So we have a technology that can capture microplastic to a really, really small size with no disposable parts. I actually have something here today. I don't know if it's the time to show.
I saw you brought a suitcase. Can you show us what's inside?
I feel like a James Bond villain walking around with this. But effectively, we developed this technology platform over a number of years. I've got some really exciting engineers. I'm sure we'd love to have you guys come down and come see what we've got going on. But we've basically been developing a technology, as you mentioned. I'm ex-Dyson, and really about innovation and development. And we started by looking at the problem. So we were understanding what comes out of the back of a washing machine, how the shedding of our garments, how they affect us and what they look like. And you probably can't see that down here, but there is, you can come have a look at the end. But this little jar represents how much microplastic comes off one garment in one wash. So there are, in the UK, as you can guess by my accent, that's where we're from, there's 24 million washing machines. I think it's pretty similar in France. And that's 70 million people washing their clothes. If you've got kids, you might wash your clothes maybe 5 times a week. You put your wash on. This is sort of 13 to 16 tons of this material entering our waterways every day. It's a terrifying amount of material. And so really we wanted to apply the technology we developed to do something really positive. And so the first product we're releasing, I'm just going to hold this like this.
Oh, thank you.
Look at this. So this is Gulp. This is the first product that we're releasing. It's a retrofittable washing machine filter. So this will fit into any washing machine in the UK and Europe. You plug your hose in the back, so you have dirty water come in and clean water coming out the back. And the product has no disposable parts or cartridges, or there's a low cost per wash. And this doesn't exist on the market yet, so this is completely new. So it's quite exciting to show you guys. If you go to gulp.online, you'll be able to pre-order one of these, and they're releasing later into January.
So that's a great technology, but wouldn't it be simpler to have it built inside the washing machines?
Yeah, thanks so much, Olivier. Yeah, I think, how did we know? Yeah, so effectively, yeah, we've been working with partners for a number of years. Beco is one of our partners. They produce about 5 million washing machines a year. So we're working on integrating this technology inside the machines. So when you buy a new washing machine, it will come included with Matter technology. We're working on another number of other manufacturers, but that's all in the pipeline. And then the final part of our business really looks at creating a material from the stuff that you capture. It's great that we've got this capture technology, but really what you're doing is creating a new waste stream. So we've been working on a new material from the stuff that we capture, and now we're in a process. I'm currently raising $10 million to do Series A, and we are going to do an industrial version of our technology. So we're scaling it up for wastewater treatment plants, textiles manufacturing, some of them big, large applications for that.
You just mentioned that you're starting to use this waste stream, and what do you use that material for?
Yeah, so we think there's some really exciting opportunities with this. As I mentioned before, the cradle-to-cradle principles, some of you may have known this, it's kind of the foundations of what is now referred to as circular economy. Really, materials is something I'm really passionate about, and I love materials. And we discussed this earlier about materials are often, they're in the wrong, we don't have a materials problem, we just have a materials in the wrong place problem. So it's how do you turn that materials into something that's valuable? And for us, a low carbon insulation material is something really exciting that we're trying to look at. And we think that's an initial step. Everybody was like, nobody's ever going to send it back. Nobody will ever do it. And my team, I think there's some people are in the audience, have been working on delivering this, and we've got a partnership with a company called Small. They've got 250,000 customers, and we've been inundated, absolutely. Every time I open my post, it's full of microplastics. So it's going really well, and we're in the process of building that scheme going forward.
Great, thank you. Jamie, so we talked about microplastics coming from agricultural microcapsules or home care microcapsules. We can change them, use biodegradable material. We talked about microplastics coming from washing our clothes. We talked with Imogen, we talked about microplastic in facial scrubs. Is that it? Is that all the sources of microplastics?
No, so I participate on a number of European Commission workshops on microplastics. And the good point about that is there are hundreds of people in the workshops, from political leaders in Sweden, political leaders across the whole of Europe, NGOs, and people are aware of microplastics now, and people are doing so many studies to understand the origin of microplastics. And the data is being updated all the time. But what we know today is about 5% of microplastics comes from synthetic fibers, from washing up, laundry. About 10 to 15% of microplastics comes from microplastics intentionally added to products. So where does this other 80% come from? Well, the other 80%, we see one of the biggest causes is car tires. So when you're driving your car, the abrasion between your car tire and the road causes the generation of microplastics that then enter into the water systems and go to the ocean. Another big source is paints and coatings. So the coatings on your buildings, the coatings on the roads, the coatings of your cars. With light, the polymers degrade, and then with weather, the polymers are released in the form of microplastics. And we find today there's over 1 million tons of microplastic particles released from coatings alone. This is huge data, and it hasn't been released publicly yet, but it's in the European Commission work at the moment.
It has today.
It has today. Today?
No.
Well, now it has. Maybe it's a quick scoop. and so what we're finding now is the weathering of materials is huge cause of microplastic pollution. And so it's really a question of how we resolve that too. And so I think it's another call to action. I think in addition to creating new regulation to eliminate microplastics from products, I believe we should create new regulation to curb the weathering of materials, and in terms of what materials can be used for coatings, in terms of their mechanical and optical stability.
But what we just heard is a bit terrifying, so I understand why we didn't release that number publicly. Do we have solutions for that kind of microplastics?
We do. So one of the solutions people tend to think about is, why don't we replace all of these materials with a biodegradable alternative? But as Imogen was saying earlier, something may be biodegradable in certain environments, but not in all environments. And the thing is, often with plastics, is in the ocean, they go to the bottom of the ocean, where there's no oxygen and there's no light. So it's unlikely to biodegrade in those environments. So our approach is a little bit different. We create encapsulated ingredients. It represents about 50% of our business today. 50% of our business in agriculture, home and personal care, and 50% is on materials. And we add new ingredients to coatings and materials that help make them more light resistant and more abrasion resistant. So we can create materials now, or an ingredient for materials, that can reduce the abrasion by 90%, which means these materials can last 10 times longer, which means we're not going to address the whole world, but if we did address the global problem, you have 1 million tons a year that has the potential of eliminating 900,000 tons of microplastic pollution every year. And it's by making materials more resistant opposed to making them more biodegradable.
So that means that my car tires will last 10 times longer.
Depends on where you buy them from. But I know there's a lot of wonderful companies now, big multinational companies, who understand the problem too. And I think one of the things with multinationals is they are seeing the problem, they're seeing where the trend of the industry is going, and some very big companies are developing really good solutions today. And I think that's something we can all be hopeful of and for.
That's an important point that you're mentioning. In large corporates, how do they react? Because they are part of that problem. So when you come, your startup, and you're coming with that kind of solutions, do they try to kill you, or are they receptive?
Yeah, okay, I can answer this one. I think it's a real fine balancing act, right? We were talking earlier, and we were sort of saying we were working in microplastics. Like, oh, are you competitors? And I'm like, well, there's plenty of microplastics around for everybody. I don't really see it like this. So. Matter of sort of founding principle for us is about not having a blame game with this. I think fundamentally, I was listening. I've been incredibly amazed by some of the people that have been here at this event in ChangeNOW. And there was one lady we were talking to, and she was leading a young person's event that was talking about how they influence some of the big business. And they were saying that some of the leaders in these large FMCGs companies, they're not being influenced by the numbers or the statistics, but they're being by their kids calling them out. And there's a terrifying part, right? But fundamentally, us as an audience, and we're all consumers in our own way, have a responsibility to help drive that. But working with big business is that they're looking for solutions, but they need solutions that are sustainable and they are scalable. And that's really what we wanted to do as a business when we started out designing the technology, not having disposable parts, not using loads of water and energy to be able to do what we do. So finding technology that's scalable and sustainable allows them really easily to kind of understand exactly what you're doing. And they are looking to do the right thing. There's so much shareholder pressure right now. The money in this space is moving very quickly, and it has to. Fundamentally, it's bad business to be polluting. At the end of the day, that is fundamentally waste, and waste is costing somebody money. So I think as startups, there are a lot of corporate venture arms bringing stuff in, but also it's about like about being able to understand their language. You know, big business, they want to act in a certain way. They have their own vocabulary that you have to learn, and it can be frustrating. You kind of want to shake people and be like, just make this happen. But at the same time, you know, when we get one of these products in one washing machine, that's millions of units. And really, you know, I'm not interested in 1,000 units. That's not really going to move the needle right here. You know, what we're talking about with some of these technologies is that we need to be in, this needs to be in millions of homes across the world in a very short period of time. We have a very short window to make this impact. And I think really that's what we're looking to do. You need super high growth, and companies see that.
Great. And Jamie, what is your experience with large corporates?
I would say that the industry has changed significantly in the past 6 years. I think on one side, if you want to make a global impact fast, you have to work with global manufacturers now. But what I've seen is that these global manufacturers, they have young kids. They have activist investors. They see the regulation, they see where the market is going. And now you have a lot of CEOs of big companies that are really driving their companies forward towards sustainable and innovative solutions. And what I have noticed with multinationals, which I'm really pleased to say, is that you see a lot of small companies that tend to talk about sustainability, but then you see their products, and their products are not so sustainable. One of the nice points about global multinationals is that they hold themselves to a really high standard because their reputation can't allow for, you know, greenwashing in a way. So what I particularly like about global multinationals is when they say their products are biodegradable now, when they say their products are bio-based, more often than not, you can believe them. And these companies are really driving the sustainability agenda forward. And so I'm really proud that we're living in this time today.
Great. So what I learned is that Amy needs to target specifically the kids of the CEOs of large corporates so that we have quick and scalable impact. Adam, I've got a question for you. So you presented GURP and your technology, and we understood that you want to go further. Could you tell us what's next on your roadmap?
Yeah, sure. So I think it's super exciting to be working at a consumer level right now. I think fundamentally, we think that people want to do the right thing. The feedback for this has been incredible. We had one Guardian article, and we got like $100,000 worth of sales in a day. It was kind of crazy. So things are moving really, really quickly. But for us as a business, as I mentioned, impact is our roadmap. So the biggest impact has to be from the largest sources. So we were talking about wastewater treatment plants. At the minute in the UK, there's about we have combined water network where the water is exiting. Every time it rains, the water from the drains and the sewage combine and they go out. And they're seeing the breaches of their permits. Last year it was 400,000 times. This raw sewage is getting out in the natural environment, which is crazy. We're paying for that. That's being paid for by the taxpayer. So these are real opportunities. You know, these companies are being fined. Suffolk Water was fined £90 million last year. They need technology that's moving really quickly. So we're building industrial versions of this. We're raising money to do that. And I think the companies that we speak to, the technology, we need systems that are more resilient. They need to deal with high volumes of water in storm scenarios, but also droughts. We need to look at recycling of water and the way that works. Our relationship with water is going to change. It's some of the most precious resource in the universe that we find in liquid water is not particularly easy to find in our solar system. So we should treat it a little bit better than what we do. It's not something that's disposable. So 1/6 of all the water that comes out of your home currently is being pumped through a washing machine. It's a small part, but I think industrialization is really what we have to work on.
Great, thank you. And Jamie, we have another few minutes. Do you want to share a last thought about microplastics and what you do?
I think on our side, in terms of what we do, I really believe we have an impact agenda too, and we help a lot of companies deliver on their impact agenda. But as kind of a last thought, because I think it hasn't really been discussed so much today, is that microplastics, they don't degrade for hundreds of years. It is really difficult to remove them. And one of the issues with microplastics is if we don't act now, the concentration could be so high that it could be catastrophic for our environment, catastrophic for biodiversity, catastrophic for food safety, and catastrophic for human health. So I think they are they're an invisible problem, but if we don't act now, they could be a really serious problem. I think there's hope, though. Where the hope comes is that NGOs are putting lots of pressure on big companies and regulatory bodies. Regulatory bodies are moving the needle and implementing regulation. You have innovative companies that are trying to eliminate or replace microplastics. And you have big multinationals that are also on this roadmap too. So I think there's hope, but I think everyone in this room has to continue to act and to continue to act now.
Thank you very much. It's a big round of applause. Just to give Adam some time to take his suitcase. And so I think what we heard today for this session was great. We heard about what is microplastic. Even if we don't see them, we understand that that's a big issue, a big pollution, and we need to act. The best way to act is to try to curb the quantity of microplastics that will end up in the environment. So this is everybody's action that can really work on this. And then we saw some good solutions and entrepreneurs that come with great inventions to help us get rid of that microplastic pollution. And we thank them for this. So thank you, everyone. That was a great session. I hope you enjoyed it. And please enjoy the last moments of Change Now. Thank you.